Hello, dear aspirants. This is Dr. Sourav sir's class. We are solving the National Boards of Higher Mathematics previous year questions. So this question is the from year 2021. So the question says that let A be an arbitrary real 5 cross 5 row equivalent to this matrix. Okay, so two matrices are row equivalent if they have the same row space. We all know that. So the row space of the two matrix will be same. So what are my row space will be okay. Okay. So for each of the following statements, say state whether it is true or false. So the options are: the first two rows of A are linearly independent. We can take this matrix also. They told us that the first two rows of A are linearly independent. If we take the matrix like, yeah, 0, 0, 0, 0, 0, and the third row will come in our last. So this is my new matrix, and those two matrices are row equivalent. So what? So from this thing, we can say that our option A is false, because the first two of row are always not linearly independent. We can easily see that in this case. So now the option B says what? This says last four rows of A generate a space of dimension at least 2. Okay. So again we have to think. Let me change my color first. Yeah, to the blue one. Okay. So our rank of A is what? My 3. So A has 3 linearly independent rows. That means, so W of span R2, R3, let us take these 4, R4 and R5. Then what will happen? Then the most favorable case, we will get to our R2 and R3 be the row 0. That means this. Take R2 and R3 both are 0. Then our R4 and R5 will what? Will be what? Either this one or this one or this one. So these three are my linearly independent. So the rank of sorry, the dimension of this W will be my greater than equals to 2, because at least these two are linearly independent. So then it will be 2. Otherwise, if these three are linearly independent, then it will be 3. So our dimension of W will be always greater than equals to 2 in this case. Now for C, that they tells us the first two columns of A are linearly independent. Again we have to think in another way. So let us take our this. The matrix is the permutation of the columns only. So So I am getting that this will be my AN. So it is, yeah. So we will have what? So our A1 will be my PC1. Our, yeah, yeah. So our A2 will be my PC2 and dot dot dot. AN will be PCN. Now what will happen? So we can take as our these two are these. If we take the first two columns are linearly dependent, sorry, independent, then we will get, yeah. The K is a real number here. So our, yeah, this is my K, and PC1 plus our PC2 is equals to 0. No, I don't want to do that. I want to do the P thing out. Okay. Then it will be easier to see because this is very easy question. So P will be outside. Then we have our KC1 here and also our KC2 inside. Then we can say that if as our P cannot be 0 because the okay, we all know that. So our KC1, am I, oh sorry, that will be K1 K2, yeah, K1 C1 and K2 C2 will be my 0. So our C1 and C2 are the columns of the matrix. So these which tells us these two are linearly independent. So our option C is true. Now we have to check about our option D. So option D tells us what? The last four columns of A generate a space of dimension 3. Yeah, that will also be true because, okay, let me tell you in details. So as our C3, C2 and C4 are my linearly independent, we can see that. So that means what? Our A3, A2 and A4 are also linearly independent by the previous argument. So we can say that the dimension of span will be what? That is equals to my, will be my equals to 3. So our option D is also true. So what are the correct answers? Our A is false, B, C, D and okay. So our B, C and D is true. So this is the answer of this question. Hope you understood and studying hard for your examinations. So wish you best luck, guys.